The Grundfos Magna 3 features both operating modes and control modes. In order to use control modes, the pump will have to remain in normal operating mode, which is the factory default. The Magna 3 also features 3 additional operating modes: start-stop, minimum, and maximum. When in normal operating mode, the Magna 3 gives you the full range of control mode options you would expect from a state-of-the-art circulator pump. But the intelligent auto-adapt and flow-adapt modes really set the Magna 3 apart from the competition. Note that the flow limit control function can be applied to all Magna 3 control modes. The constant pressure mode emulates the performance of a fixed-speed pump, adjusted to a set duty point and running at a constant speed. With the Magna 3, 0 to 100% is no longer controlled on the pressure axis, but on the flow axis. In effect, this means that any given Magna 3 model will have a higher maximum flow than previous models with the same maximum head. However, the variable speed Magna 3 will give you access to a much wider range of control algorithms. The constant pressure control mode is suited for variable flow systems with very low pipe pressure losses, and in open systems where pipe pressure loss is subordinate to static head. In proportional pressure control mode, which is used in circulating systems, the pump continuously adapts its performance to varying flow and pressure demands. The Magna 3 is aware of its RPM rate, power consumption and flow, and calculates where the actual duty point is in the QH table based on these data. The pump moves back and forth on the regulation curve by measuring pump torque and adapting RPM. If there is little or no resistance, the system is open and the pump ramps up. If resistance is high, valves are closed and the pump ramps down. In auto-adapt control mode, which is the factory default, the pump continuously adjusts its proportional pressure curve and automatically sets a more efficient one without compromising on comfort. This eliminates the need for manual adjustments in 80% of all installations. In auto-adapt mode, the default proportional pressure curve has a set point of 55% of the pump's maximum head. As valves begin to open, the duty point will begin to move along this curve, ramp up RPM, and increase flow discharge. If the system reaches its maximum curve, the duty point will follow this curve and create a new proportional pressure curve based on the new system duty point. Then the process starts all over again. The Flow Adapt control mode combines the Auto Adapt control mode and the Flow Limit control function. The default flow limit setting in Flow Adapt control mode is the intersection between Auto Adapt's proportional pressure and maximum curves. This enables the Magna 3 to make sure the flow rate is never exceeded, which can save the cost of a separate pump throttling valve. In heating applications, your flow limit should be the nominal duty point Q. This is calculated by converting system heat demand into kilocalories per hour using the 0.86 conversion factor and dividing this number by the temperature difference between the flow pipe and return pipe. For example, imagine a new 200 square metre home with a specified heat demand of 10 kilowatts and heated by modern radiators with a 20 degrees Celsius temperature difference between the flow pipe and return pipe. To calculate the Magna 3's nominal duty point, and thus also its flow limit, you would multiply 10 kilowatts by 0.86 to get a converted heat demand of 8.6 kilocalories per hour. Divided by 20, this gives you a nominal duty point of 0.43 cubic meters per hour, which you then enter as the pump's flow limit. Finally, a constant temperature control mode is used in variable flow systems, requiring a constant liquid temperature at a user-defined point. The pump is in charge of flow, and no external temperature controllers are necessary. But an external temperature sensor can be used to provide set point input that differs from the temperature measured locally by the pump. This control mode is designed primarily for broad spectrum use in domestic hot water circulation, and is thus intentionally slow regulated.